Hello, hello. Alright, I think it's working. Yeah, alright. So, today, as the title says, we're gonna try to do some kicad stuff. I haven't used kicad that much yet, so it's always gonna be a learning experience for me too. I have made a list of things, list of parts that I want to use. So we're just gonna design the circuit around that. Yes, I'm just gonna pull it up really quickly. Here, yes, here. Alright, I think that's everything. Alright, so the main thing, of course, is that this is gonna be designed by, powered by an ESP32, and the whole idea is it's gonna be a music player, and I'm gonna try to make it at least a little bit of a higher end music player, because it's gonna have a nice 32-bit DAC, hopefully. Alright, I'm going to change the wherever it is. I'm trying to change for now the size of the thing. Alright, so where was it to do this? Okay, so the first thing, and I already cannot find it. Here? No, I don't think so. I'm trying to change the size from A4 to A3, so we have a little bit more space to work with. But I totally forgot how to do that. Try the green thing at the top. Which one do you mean? No, I think that's the... It just puts you in the PCB editor. But yeah, hello, welcome to the stream. Oh man, I've just done this like 2 days ago and I totally forgot already. Alright, let me just Google it. I'm not gonna stumble around blindly forever. Select page settings. Where are page settings? Here? Hmm. Stumbling around trying to Alt P, okay. No, that doesn't do anything. Come on. Okay. I'm now reading an introduction to link schematics. Amazing. Grid snapping. Yes, symbols. Yes, yes. I know all about that. I'm gonna just Control F and try to find it that way. Oh, here. Okay. Page settings tool. There's a page settings tool somewhere here. There it is. Oh my god, okay. I found it, everything's fine. Okay, we can finally start. Amazing, alright. Let's just forget that first 8 minutes of the stream. Alright, ESP32 S3. Yes, yes. I'm gonna place it a bit like here, maybe. Alright. Yes, thank you for the applause. Alright, let's add a ground. Now, I'm like pretty sure I just have to bridge all of these together. Alright. Okay, so we have this. Yeah, now what? We have to have some kind of a UART way. So to communicate, I think. So let me just make some test points. Let's call it, yeah, it can be TP1 and it will be UART TX. Alright. And then clone it. It's gonna be, okay, I'm gonna try to do it like so the text is not like together. You can actually see what's happening. Alright. TP2, it will be UART RX. Alright. So yeah, that's okay, that's done. Okay, what else? I mean, what should we tackle next? I feel like maybe the charging part. I feel like from what I've seen, it's one of the only parts that I won't need a custom symbol for. So let's just do that first. There's a BQ charging chip. BQ. Which one? 24072. 24072. 24072. RGT, yes, this one. What are you building? I will be building, it's my first PCB project. I'm gonna be trying to build a music player with a relatively high-end, you know, DAC. It's a 32-bit digital to analog converter. It should be pretty good, but we will see, of course, how it goes. And yeah, I'm planning to have like a rotary encoder as a well, not click, but like a wheel, like on an iPod. That's the basic idea. I've made a list of all the parts, every like amplifier, stuff like that, so yeah. Alright, I can probably already tie this to ground. For the rest, I'm gonna need the data sheet, so I'm just gonna pull that up if I can find it relatively quickly. It's the BQ2, yeah, 240 data sheet, okay. Huh. Ah, so the BQ lines of chips are from Texas Instruments. That's interesting. Huh. Oh no, I have to. Okay, I only have 2 monitors, so I mean no, I guess I can. I don't need to like see both this and this. I can. Oh, the OBS is stuck. I cannot resize it. Amazing. I'm gonna resize this instead. Alright. I guess they make more than TI-83, yeah. Yeah. Alright, this is what I wanted to see. So this is the typical application circuit. You cannot see it right now. I may just, you know what? I'm gonna just do the whole screen, not just the kicad. Yeah, so you can see what's happening. So this is what we want to replicate. This typical application circuit. So yeah, System on-off control should probably be driven by one of the GPIOs. I guess all of these just tie them to ground. And then enable to... What is the system line? I'm gonna have to read the actually read. Dang it, I'm gonna have to read. Ooh, there's LEDs. Do I need the LEDs? Or just the diodes? Or just don't do anything? Alright, let me just recreate what I can for now. So, let's just tie the grounds to ground, I guess. So the CE goes to ground. Like that. The TM-WAR and enable one. Okay, so I can just do this. Enable 2 goes to here, and also out. So out goes with enable 2 to the system bus, I guess. Oh, okay, this is the battery. So this is the battery. So yeah, and this is the plus, minus, yes, this is the temperature sensor. Alright. System on-off control, and the 1K from the system output to the power good, and the 1K from the system output to the charging. I don't think we need the diodes at all. Alright, and then the input from the USB-C port, I think, is gonna be this, and it's gonna have a capacitor 1 microfarad to VSS, and then these two, whatever they need. Okay, I think I understood that, probably. So let's just do the capacitor now. Of course it's gonna be like that. It's to ground. Right. Might as well be C1, but the value must be 1 microfarad. Okay. The ilim and iset, let's just get those out of the way now. So, resistor, I'm trying to remember which YouTuber mentioned you for helping him out. That's why I dropped this up. Oh, yeah, I'm pretty sure it was Joey Does Tech. I helped him with a graphics card once. That's probably where you're from. And yeah, nice that you're here. Alright, and then tie both of this to ground. Yeah, I'm more into graphics cards, but I am I guess branching out a bit. Just recently learned how to use kicad, so trying to do like a, no, I wouldn't call it the simplest first project, but a first project. And for the, why not just stream it along the way? So that's gonna be 1.18k, and this will be 1.13k. I have no idea how I'm gonna get those resistors. I'm gonna salvage most of them. Honestly, just nice to find this kind of stuff. Yeah, I mean that's true. That's true. Oh, there's another capacitor sneaky between the bat and the other one. The out is the system rail, right? So let's just while we're here, let's just do like a line here. And do the 3.3 volt power rail. Like this. Alright, so we have the output. Now the bat should is there a battery symbol in kicad? Huh, I think there is. Battery cell, but there's no like I would need like a battery with a temp sensor. I guess I'm not sure if my battery is even gonna have a temp sensor. So for now I'm just gonna leave the battery here as it being like this, maybe like this somewhere. Tie of course the other part to ground. Then this to here. Oh, it's a bit whatever. And just do the battery rail, because there's a possibility I might need it in the future. So let's just do it right now. And also another ground, because another capacitor, right? That's supposed to be a capacitor right here. Yep. And the capacitor is how much? 4.7 microfarad. I think this is a pretty standard value. Have you seen any of the DDoS dude stuff? You know the backexpression, but oh, the DOS dude. Yeah. Of course. Yes. I've seen a bunch of his stuff. Yeah, the legacy macOS patcher, the swapping around nans everywhere, CPU swap videos. Yeah. I've watched a lot. He's a pretty knowledgeable guy. Yeah, I'm not that much of a Mac person. I mean, I own a Mac, but and I use it for streaming, but only for streaming only. Alright, so we have this done. Temperature sensor. I'm gonna read around because is there like a you know, a possibility, like if there is no temp sensor. Wow, changes from revision December 2008. This is old, I see. Okay, yeah, comparison table. TS. I'm trying to find the pin. TS, yeah. External and connect the TS output to the thermistor. TS monitors a 10K. Connect for TS function connect a 10K resistor. Yeah, alright. So just a 10K resistor to ground. Right, to ground. Exactly. I got my Mac from a guy at the recycling center. It's running Linux. Let's go, let's go, let's go. That's great. I'm a huge Linux fan. I run it on all my laptops. What distro do you use? Oh, hello Techno. Welcome to my humble stream. I am making a device, or we are making a device. So, I mean, just laying out the schematics first. Yeah, to ground. Alright, so a 10K resistor from here to ground. I'm just gonna scroll back up to this portion. Alright, so somewhere like here, then a resistor from here to ground. Just standard Ubuntu. Ah, alright, alright. That's a alright choice. Alright, and the power good and charge thing needs to have a 1K resistor both to the output. Alright, yeah, I can do that. So for that I would actually take this, put it this thing, yeah, put it way. Oh, alright, it's just gonna draw the thing. That's cool. Alright, so I'm gonna do this, and then I'm gonna add the resistors over here. Just like this. 1, 2. And then connect them up. So this one to this one, and then this one to the other one. Since I don't even have to remember it. Oops. I could like... Okay, it's a bit ugly, whatever. Functional. Or can I just delete that? Yeah, I can delete that. Alright. So they're both 1K. Let me just put 1K in here. This takes me back to my old electric days many years ago. Oh, were you making schematics too? That's cool, that's cool. It's some new techno lore I haven't heard about yet. Alright, so enable 2 needs to go straight into the system bus. I mean, sure, why not? Let me just wire that up. Alright. And the TD is for... What is the TD for? What is the TS? ILM, out, enable to. I don't see a TD. What is pin 15? It is TD, alright. So what does TD do? TD. Termination disable input. Connect TD to high to disable charger termination. Connect TD to VSS to enable charger termination. Check during startup only and cannot be changed during operation. See the TD section in this datasheet for a description of the behavior and termination is disabled. TD is internally pulled down to VSS. It's not TV unconnected. Alright, is there like the TD pin here? Did I just miss it? I just want the normal operation. I don't really. Okay, so this is TS 9. Okay, this is 10. This is the sys off. System on off control. Why is it called like this here and like that there? Okay, let's read up on that. What the TD does. Detailed overview. All right. Oh, amazing. Yes, with a pen and paper. Ooh, ooh. I gotta go for a little bit. Yeah. All right. All right. Thank you. Thank you. Thanks for being here. Technical drawings. All right. Let's see what the TD pin is for. TD. It goes to a NAND gate, and then to an AND gate, and then to the charge control. What does that even mean? Alright, let me just do a Control F on the whole thing and just do TD. Terminate. Okay, this is the detailed description. Termination disable. The BQ contain a TD input that allows termination to be enabled disabled. Connect TD to a logic high to disable charge termination. When termination is disabled, the device goes through the pre-charge, fast charge and CV phases, then remains in the CV phase. During the CV phase, the charger maintains the output voltage at BAT equal to V BAT and charging current does not terminate. The charge current is set by I charge or I in max, whichever is less. Battery detection is not performed. The charge output is high in impedance once the current falls below I term and does not go low until the input or CE are toggled. Termination is disabled. The pre-charge and fast charge safety timers are also disabled. Battery pack temperature sensing TS is disabled if TD pin is high and the TS pin is uncontrolled or pull up to VIN. Oh, what? You know, I just read that, but I'm not sure if I read that. What does that even mean? What should it be pulled to? I guess this is like the fast charging enable disable. So What should I do? Should I do like a transistor for it, that the gate is like, because you have those like normally high, normally low, right? Because I don't want to. I don't know if I should do it like straight to the GPIO, because maybe then it won't be like uh, it won't be like a good what was I about to say? Uh, if like the thing doesn't fully initialize, it might think that there is the output is like floating, and cannot be floating. Hmm. I'm gonna Google some more about this. What does the TSP do? Okay. So, termination disabled. Okay, TD logic low. Normal charging operation. The device performs fast charge, constant. Okay, charging terminates automatically when current falls below. Okay, and if one, it is disabled. So goes through pre-charge faster. Holding the output. Regulated battery voltage. Charge current continues at whatever level results from CV regulation. Lower. No charge termination occurs, meaning the charger never declares charge complete. Charge pins, charge status output goes high impedance. Safety timers are disabled. TSP. Okay, with the termination disabled, the charger will continuously apply voltage to the battery, which could overstress. This mode is used for system power supply or battery testing. Not recommended. So I should just pull it low, right? Yeah, I think so. Let's just pull it low, and it should be good. That's what I think. I may be just totally wrong on this, but I think that's what I. Okay, next thing to do. So this is our charging circuit. This is the battery. Uh, we should do a USB-C port totally. Yeah, USB data plus, the USB data minus. Let's do the port. I think that would be a good idea. So a symbol for the USB-C port. USB-C plug 2.0. Yes, that's exactly what I wanted. So I'm just gonna do it like here, somewhere like here. Alright, tie both of these to ground, of course. Amazing. CC Vicon. What does that mean? Let me just quickly check. Alright, for now I'm just gonna wire this to this. So alright, VBus will probably be the input, right? So let's do this and let's do power rail. It's gonna be like VBus, right? Alright. Now let's just connect VBus to VBus. Cool. Okay, that's already wired. What are those external pins for? Man, I have some things to learn. But yeah, I guess this should like this setup would probably like power something. Let's do the electrical checker. See what it thinks about this. How many issues? Okay, I know they're not connected, whatever. Whatever. Alright, yeah, I was supposed to use like a power flag, yes, to signify where the power is coming from. So here it's coming from here, the battery. Here I'm gonna put a power flag. And I'm gonna put a power flag on the output too, right here. Alright, now I think it will be much happier with the there's one more error now. Oh, whatever. Just gonna disable. Just delete that. Forget this ever happened. Oh, I mean, it didn't give me an error here, so I guess I'm gonna keep that. Tech Hobbyist, welcome to the stream. Sorry I didn't see your message. No, that's not an Atmega, this is a ESP32 chip. I'm working on my first kicad project. It's gonna be hopefully a relatively nice music player that's gonna have a 32-bit digital to analog converter and some other goodies. But yeah, I'm just starting out, so I might do stuff wrong. This is the charging circuit that we did so far. Right now I'm very much trying to figure out how to wire up the USB-C port. Alright, USB-C V-bus to the VIN. Alright, yeah, we can do a fuse, right? Or I don't think I have a fuse in my spare parts. So I mean, in the Nintendo Switch it was called the unpoppable fuse, so I doubt it will sort of save the device. Ground to ground, yes, CC1 and CC2. For charging as a sync UFP, you must implement pull-down resistors from each CC pin to ground. This tells the source that the device is attached. But why is there only one CC pin? Do I have a bad USB port? Yeah, I have no idea. What is the... Why are there more data pins now? Alright, let's use this one. I think it'll be maybe better. So let's just take both of these, just move them up, delete that link, delete the port, rotate this one like this. No, that's not how it's supposed to be. No, I just want this to be gone, please. Alright, now we connect this to this. I'm gonna look at the chat. Oh, alright. I don't, I have both of my monitors covered by stuff. Alright, so data minus should go to data minus. Why is there 2 data minuses, 2 data pluses? You know what, I'm just gonna wire those together. I think that's how you're supposed to do it. Alright, so... And this is how you're supposed to... What am I doing? That's so unpretty. Can I like make it a bit prettier? Please. Come on. Delete everything. Just make it work again. Alright. And then delete this. Alright, I think I can work with this now. So this to this, this to here. Sure. Alright, I think I need resistors. Oh, by the way, I can just move this here. Okay. I need resistors from what I see. So let me just place some resistors. One here and another one. I only need one, I think. Okay. From CC1, so you can move it a bit to the left, like here, alright. And CC2, just to ground, and then the other one to ground too, but through a resistor. Alright, alright. I hope I'm doing this correctly. If there is someone that knows more about what I'm doing, feel free to tell me that I am doing something very wrong. Oh, alright, 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 alright. The the charge pin, uh, one of these, yeah, this, through a resistor. We don't actually want to connect it here because we can connect it instead. I can just delete this. Can connect it to our thing. Oh my god, this is so awful. Let's connect it to pin like whatever, like 45. And then what we can do is we can measure the charging. It will tell us you know, how much percent the battery has left. So that's good, that's good. So I have this done, this done. This is intent for alternative. Okay, so I can just leave those unconnected and it should be good. Alright. I think we have something. Guys, we have something. We have a charging thing done. That's already a huge plus. So, what next? From what I see, next part should be. All right, let's see what stuff we have. We have oh yeah, the RAM. Some RAM will be good probably. Uh, no, not this. Control Z. Alright. Now it's gonna be pass. This is 8 megabytes of RAM. Alright, let's just see what is what. So yeah, CE, then SIO 1 is this, SIO, it's free, right? SIO 2, yeah, okay, so this is the right footprint. Where to place it? Like, probably somewhere here. It wants 3.3, I think, right? Yeah, it's a 3.3 thing. So let's give it to it if it wants it. Alright, let's first do ground, then 3.3 volts. Amazing. Is there anything new in chat? No, not yet. 26. Okay, hold on, I have to pull up another ESP32 S3 pin out diagram. Specifically this one. Yeah. I have to like zoom in. Jeez. Cannot read anything. Alright, so this is saying 26. Then the okay. Let's do the CE first. So or we have SCLK, SIO0, SIO1, SIO2, SIO3, alright. VCC ground. So okay, so CS is CE, I guess. So that should be connected to GPIO 26. 26 is VDD SDIO. I have no idea where that is here. Just straight up pin 26 is no GPIO 26. Hold on. GPIO 16, 23. Where is 26? Dark one. So that's gonna be pin 15. Why does it say GPIO 10 here? Huh, this is quite confusing. For me. Something is not right. Okay, so this is the pin layout. One. Okay, so I can say this is 22, 23, 24, 25, 26. Dang it. Need like a tutorial. Uh, oh, hello, Sala. Sorry, I'm not reading chat too much. I am right now trying to think about how to uh, wire up RAM. Uh, yeah, I'm building like a music player based on the ESP32 and a pretty decent DAC. Uh, but yeah, this is my first project using kicad, so yeah, it shows. Uh, you fix laptops? Yeah. I do fix laptops, but I mainly fix GPUs. I've seen like but yeah, I fix laptops too. Some game consoles, not all, but yeah, I'm pretty like diverse in the electronic space. Uh, how did you learn about it? Yeah, mostly YouTube, of course. I do go to a school, uh, IT type of school, but I mostly learned there more networking. No, not really more hardware, since I already have a bit of knowledge. Such lovely. Yeah, thank you. All right. Yeah, right now I'm just trying to figure out what pin is what. because the dev board pinout is different than the IC pinout, and the IC pinout is different than other things. No, I want to learn something like that. To be honest, it's really nice to. Do you know how to do PCBs? Yeah, I mean, this is my first project, like I'm saying. I've never manufactured a PCB before. I never even got to the point of doing a PCB before. This is like my first time. Uh, so yeah, I think it will be fun. I have worked a lot on PCBs, but I never made my own, so it should be pretty nice. Uh, Holy keyboard! It sounds awesome. I mean, it's a Logitech G5 G513, I think that's what it's called. I mean, it sounds nice. The RGB is awesome, but there is an issue. Some keys either stick or they don't type at all. So I have to press them really hard. That's why you hear the clicking sounds. Yeah, I would get myself a better one probably. Sometimes it sounds crazy. Yeah, I mean I really have to press down really hard for it to register. That's why it sounds like that. All right. So I'm pretty sure now I know how to do it. I mean, we will see soon enough. Let's just reverse that because I think these are more the pins that I need. So SIO3 I do to SPA HD. So to this one, so it'll be cool. Yeah, like this. Then VCC of course like that. SIO2 to SPIWP. So like that. Then GPIO 33 for the chip select, I guess. Oops, I meant to do it like that, yeah. Then GPIO 35 is the thing that's needed here for the clock. Okay, so I guess these things are like this, and then SIO0 goes to 35. Oh, okay. Wait, I have to check with the data sheet. Hold on. Okay, so 0 is SI. 0 is SI. Alright, so if 0 is SI, then I should have done this to the 35 and not that one. Oops. So this I delete, and then the clock itself to the 36. It looks a bit like spaghetti, but and then 0 SCI1 goes to 37. This seems really weird to me. I feel like I'm doing it wrong. I'm gonna have one of my friends look at the schematic and see if anything I'm doing is right. Oh, they stick because you have it old. I mean, I have it. I have had it for 1 year now, exactly. So, I mean, for keyboards, I mean, I have keyboards that are 30 years old, even older. So, and that still work without an issue. So, I mean, kinda sucks. Uh, yeah, I'm not reading chat as much because it's I have a lot of things open at the moment, and so I have to switch between one and the second. What app do you use? I use kicad for doing schematics and PCB. Fritzing. I have not heard about that app yet. Think using ChatGPT for long-term use for electrical programming engineering isn't good. Uh, that's a great question. I mean, I use it, of course, but yeah, I'm not sure. I mean, uh, I just wing it with ChatGPT. Like if I have no idea, it will usually lead me in the right direction, but more research is required always. It it's best to like let ChatGPT lead you onto something to find it out, but then actually do your own research with that info. So like right here, uh, off screen, I have been using it to trying to get the pins right, but I also got it from the data sheets of this RAM chip and from the other thing. Uh, and also mm, but also I am going to send it to the screenshot to someone that actually knows what they're doing, because I do have some friends. All right, so let's okay, so we have RAM, we have this, everything is great. What else did we need? uh, Hold switch and power switch, that's some good things. So the power switch will probably be just connecting, disconnecting the battery, right? I think that will be the best course of action. So let's just do that. or should we? Because I mean, the device should still like power on, like charge without the 3.3 volt rail, right? So let's just do a disconnection at the 3.3 volt rail. So the battery can still charge when the device is off, but the device will be fully off. So let's just do that. I feel like that's the best course of action. By the way, what does this thing output? I need to know. Does it like straight output 3.3? Where is the... Alright, so... Okay, so the BQ's out pin is regulated with about 200 millivolts above the battery voltage when the power source is connected. However, when the out pin is clamped, 3.4 volt. Alright, so I should have not done it like this. So let's just do the switch here, but this should not be our this should be our like pre-regulated voltage. The VBAT will go somewhere totally else, not here. Will go actually here. So VBAT will go here instead, and the 3.3 will go somewhere else because I need to do the voltage regulators first. But unfortunately, I am going to actually have to end the stream because I know it's been a short one, but there is I have some stuff to do tomorrow and I just seen the time. So yeah, thank you all for being here, and I will probably continue soon. Let me just save it.